Hey, have you ever wondered how people from the past plan, organize, and construct ways to answer problems? Well, wonder no more, for MATHalino is here to answer your convoluted mathematical inquiries and make you more MATHalino.
Oh, hey there, farmates! Did you know that nearly 100 years ago, a man named George Polya designed a four-step method to solve all kinds of problems? Understand the problem, make a plan, execute the plan, and look back and reflect. Given that the approach is simple and adoptable, it has become a standard method for problem solving.
That's right, Kiana. In fact, the method applies to any aspect of our lives where we encounter problems, not just math. Although the method appears to be simple with step 1, followed by steps 2, 3, and 4, the reality is that you will frequently need to go back and forth through the 4 steps until you have solved and reflected on a problem. With that, here are some real-life scenarios where we can apply the Polya's 4 steps in problem solving.
Mr. Jones has a total of 25 chickens and cows on his farm. How many of each does he have if altogether there are 76 feet? As we go for our first step, which is to understand the problem, we should figure out what is being asked. We can use the guide questions: what is known, what is not known, what type of answer is required, is the problem similar to other problems you've seen, or are there any important terms for which you should look up definitions? And with that, to find the number of chickens and cows on Mr. Jones' farm, we have to remember the fact that he has a total number of 25 chickens and cows.
After the first step, we are now down to the second, which is to make a plan. With this step, we can come up with some strategies for solving the problem. Common strategies include making a list, drawing a picture, eliminating possibilities, using a formula, guessing and checking, and solving a simpler related problem. And since we can formulate an equation for this one, let's use x as the total number of cows and y as the number of chickens. Identifying that chickens have 2 legs and cows have 4 legs, we can come up with these algebraic equations. That is, x plus y equals 25 and 4x plus 2y is equals to 76.
And for the third step, execute the plan. We can use the chosen strategy in step number 2 to solve the problem. But if you encounter difficulties in the chosen strategy, you may want to use other resources such as textbook for help. But since we are sticking with an algebraic equation, we can now start by using the first equation to find the value of y. And we will come up with an equation of y is equals to 25 minus x.
We'll be having the following solution. 4x plus 2y is equals to 76. 4x plus 2, open and close parenthesis, 25 minus x is equals to 76. Then after distributing 2 to 25 minus x, it will become 4x plus 50 minus 2x is equals to 76. Transposing the 50 to the right side, it will become 2x is equals to 76 minus 50. To eliminate the 2 on the left side, we need to divide both sides by 2. So, we will be having x is equals to 13. Now, let's substitute the value of x to the first equation to find the value of y. That is, y is equals to 25 minus x. Y is equals to 25 minus 13. Thus, y is equals to 12.
And finally, yet importantly, we are now heading for our last step, which is to look back and reflect. Part of step 4 is to find a way to check your answer, preferably using a different method than what you used to solve the problem. Another thing is to evaluate the method you used to solve it. In line with that, to check our solution, let's substitute the computed value to the equation 4x plus 2y is equals to 76. we have 13 cows, and since each cow has 4 legs, we will multiply 13 by 4, getting 52 total feet. Meanwhile, we have 12 chickens, and since each chicken has 2 legs, we will multiply 12 by 2, getting 22 feet. Adding up, we will have 76 total feet.
How was it, farmmates? Here's another example to practice your problem-solving skills using the Polya method. The cost of 2 tables and 3 chairs is $705. If the table costs $40 more than the chair, find the cost of the table and the chair.
Again, for our first and second step, we need to understand the problem and make a plan through it. To find the cost of 1 table and 1 chair, we have to remember that the cost of the table is $40 more than the cost of the chair, and the total cost of 2 tables and 3 chairs is $705. Let X be the cost of 1 chair, and let X plus 40 be the cost of the table. Since the total cost of 2 tables and 3 chairs is equal to $705, let our equation be 3x plus 2 times the quantity of x plus 40 quantity is equal to 705 to solve for x.
And now for our third step, we can start to execute the plan.
3x plus 2 multiplied to x plus 40 is equals to 705. After distributing 2, we will have 3x plus 2x plus 80 is equals to 705. Now we need to transpose 80 to the right side of the equation. Then we will have 5x is equals to 705 minus 80. Now, we have to isolate x by dividing it by 5 in the both sides of the equations. 5x divided by 5 is equals to 625 divided by 5. Then after that, we will now have x is equals to 125.
Since the computed value of 1 chair is 125, we can use this to find the cost of the table. $125 plus $40 is equals to $165. Therefore, 1 table costs $165.
And finally, for our last step, which is to look back and reflect. We can check our solution by substituting the computed cost of chair and table to our main equation, which is 3x plus 2 times the quantity of x plus 40, which is equal to 705. So, as we substitute, we have 3 times 125, wherein we arrive at the value of 375. Then 2 times the quantity of 125 plus 40, wherein we arrive with the value 330. So when we add those two values, 375 plus 330, we arrive with the final answer, 705. Hence, $125 is the cost of 1 chair, and $165 is the cost of 1 table.
How is it for me? Certainly, Polya's method is an effective way of solving a lot of mathematical problems. Remember, understand the problem, make the plan, execute the plan, and look back and reflect. See you next time for me. Goodbye!
Mag-isip, huwag matakot magkamali.